Welcome back, ladies and gentlemen. Dr. Robinson here again, and we're going to continue our studies. This time we're talking about compound events. So let's talk about that. So compound event consists of two or even more events that you'll be doing and with probability. So an independent event is an occurrence of one event that does not affect the probability of the other event. It's independent, has nothing to do with the other event. It doesn't care about it. So if you have to find the probability of two independent events, we use the counting principle where we would multiply the probability of the first event times the probability of the second event. If you have a dependent event where that's the occurrence of one event affects the probability of the other event, it's depending on it to come to pass. So that's dependent. So you might want to think science, independent and dependent variables. So we're going to play some of these games here. We have spinners, dice cubes, and all of that stuff. So hopefully you'll win prizes in order to be successful in compound events. So I need to review with you first the counting principle, the fundamental counting principle, and that's just the rule for finding the number of possible total outcomes. The rule basically states that if you have n possible outcomes and another independent event has n possible outcomes, then there are mn or m times n possible outcomes of the two events together. So here's our first review of the possible outcomes for this spinner and tossing this coin one time. So we want to find out how many possible outcomes are there. So we're interested in the total possible outcomes. Well, there are 1, 2, 3, 4, 5 different numbers on the spinner. And on a coin, we have heads and we have tails of the possible outcomes. So we have two different ones that can come out. According to the counting principle, we can have to multiply our two numbers. 5 times 2 will give you 10 outcomes or 10 total outcomes. So that the number of different outcomes we can have is 10, and you can list them out if you want to, but we just did this using the counting principle. So here's one for you. List all the total possible outcomes. So you should find it first using your counting principle for tossing this die and this coin. So remember, there's a dice cube. Remember how many numbers on the die cube? So there's a coin. We just mentioned that a minute ago. So see if you can find the total possible outcomes. Now I want to get to a compound event where here we have Anna tossing a cube with the dice cube numbers 1 through 6, and she's going to spin a spinner down there at the same time. What is the probability of tossing a number greater than? So a number greater than 2 on the cube. So they want a number greater than 2 on the cube and red on the spinner. Well, let's look at the dice cube first. What number is on the dice cube? 1, 2, 3, 4, 5, and 6. So those are the numbers on the dice cube. We want a number greater than or more than 2. Well, I'm going to circle, put a little box around these numbers here. Those numbers are greater than 2. So N stands for number. There's a greater than symbol, greater than 2. So how many numbers we have greater than 2? We have a total of 4 numbers, 3, 4, and 5, out of the 6 numbers. So the probability of getting a number greater than 2 would be 4 out of 6 on the dice cube. Now let's deal with the red. On the red, we have 4 different sectors. 1, 2, 3, 4 different sections. So there are 4 different sections. We're interested in the ones that are red. So red sectors. All right. So we got 3 reds. We got a red 1 here sector, red 2, and a red 3. So we got 3 red out of a total of 4 sections or sectors. So the probability of getting a red would be 3 out of 4. So now, what are we going to do with these two fractions? Well, according to the counting principle, we're going to take those two fractions, 4, 6, for the numbers that are greater than 2, and multiply it by the second fraction, which is the 3/4, the 3 read out of the 4 sectors, and get our answer. 4 times 3 is 12. 6 times 4 is 24. So our answer is 12 out of 24, and you can reduce that if you desire. So the probability of getting a number greater than 2 and red would be 12 out of 24. So I found again my numbers greater than 2 was 4 out of 6. The numbers 3, 4, and 5, and 6, 3, 4, 5, and 6. And there were 3 red sections out of the 4 total red sectors. And according to the counting principle, I take those two fractions, multiply them together, and I get 12 out of 24. I can reduce that down to 1/2, which is 50%, or 0.5. So that's a nice question. Hope you enjoyed it. Here's another compound probability question for you. Here I have my little Thais and Johan. She's going to toss a quarter that she got from Johan 5 times. So 5 times. What's the probability? And remember, probability is a number between 0 and 1. So it's a decimal, fraction, or percent. So we're going to get a fraction, decimal, or percent for our answer. So the young lady is going to toss this thing 5 times? Man, in a row? Wow. Well, and she wants to get a heads, 5 heads? That doesn't sound easy. Well, let's look at the coin. First coin. Here's our first coin. You can get either head or a tail. So the probability is 50-50, or the probability of getting a head would be 1 out of 2. So the probability on the first coin is 1 out of 2. So again, our second coin, here's our second coin, our second time she tosses this quarter. She can either get a head or a tail. So again, the probability of getting a head is what she wants is still 1 out of 2. So I can write that down there, 1 out of 2. We have a third toss. On her third toss, she still can get a head or a tail. And that's the same probability. Hopefully you notice the pattern. It's going to be the same for each one of these coins, 1 out of 2. So for the fourth coin, still head or tail, which is 1 out of 2. Bring that down. And for the fifth coin, fifth toss, still head or tail, and it's 1 out of 2. So she's trying to get 5 heads in a row. That's not easy. So we got all these fractions, 1/2, and according to the counting principle, if you're doing an independent event so many different times, you have to multiply every single one of these fractions. So we're going to multiply the top numbers. So let's multiply the top. That would be 1 times 1 times 1 times 1 times 1, which is just 1. Now let's multiply the bottom numbers, the denominator. Let's be careful now. 2 times 2 is 4. Now I got another 2 times 2 over here, which is 4, so I'll do it that way. But I got an extra 2 over here I got to bring down, so I'll bring that down. I'm still multiplying. So let's now multiply 2 times 2, 4 times 4. 4 times 4 is 16. And I still got one more 2 that I got to multiply, and 16 times 2 is 32. So the probability of getting 5 heads in a row is 1 out of 32. Boy, that doesn't sound promising. So let me just type that in my calculator, because I know 1 out of 32 does not sound good. Let me move down. So 1 out of 32, press enter. And now let me change my fraction to a decimal. I didn't mean to do that. Let me clear that. Let me change my fraction to a decimal. There we go. Press enter. Man, there it is as a decimal. Let me multiply that answer by 100 to change it to a percent. Let's pull this out. This is not looking too good, Thais. So let's take a look. As a fraction was 1 out of 32. As a decimal is 0.03125. As a percent, it's 3.12%. That's like 3%. Boy, that doesn't sound good at all. So 1 out of 32. Oh, I see I've written it as an exponent there because there are 5 1/2. That's 1/2 to the 5th power. So that's equal 1 over 32, which is still about 3% chance. And if she has a 3% chance of winning, that means she has a 97% chance of losing because either she's going to win or lose. That's not good, Thais. I don't think you're going to win this game, so I wouldn't bet any money on it. So I hope you understand what's going on. If you're not sure, rewatch the video, see what I've done so far, write down your questions, and bring them in. All right, let's reason with Josiah. Josiah forgot his last digit of his cell phone password. What's the probability that he will choose the correct digit? All right, so let's see. A digit, by the way, is a number. So he forgot a number. One number, as a matter of fact. That's the last digit, the last number. So we're looking for the last number. Now, what could be the numbers? Well, on the phone, you have 10 numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 0. So you have a total of 10 numbers that he can choose from, and that would be our denominator. But we're looking for just one of those numbers. So one of them is right. So his probability would be just 1 out of 10. So that would be a 10% chance of getting right, or 0.1 if you want. So 1 out of 10, only 1 out of 10 numbers would be correct for him to get. So good luck, Josiah. I hope you try it and don't get locked out of your phone. So let's look at another one. Josiah forgot his last digit of his cell phone password. Now he remembered that the digit was an even number. So he remembered something. So he remembered that it was even. Explain how does this change his probability. So we got to do a little explaining here. So even numbers on the cell phone. What are those even numbers? Let's pull this out. 0, 2, 4, 6, 8. Even numbers are numbers that you can divide by 2 and not get a remainder. So that's even number definition, because you see that word a lot in probability. So here are the even numbers. There are 5 of them altogether. So out of the 5, 1 of them is the right number. So his chances are better because now he's got to pick 1 out of 5 numbers, whereas before it was 1 out of 10. Now it's 1 out of 5. So his chances just really went up. So 1 out of 5 is 0.2 or 20%. So he has a 20% chance of getting it right. So that's better. So he had a 10% chance. So now his chances went up by 10%. And the reason why is because he remembered one of the numbers that one number could be even. So he doesn't have to worry about the odd numbers. So he's not going to pick those. And remember, you don't want to get locked out of your phone. So be careful, Josiah, when you select. I hope you understand what's going on so far. If you're not sure, rewatch the video and write down your questions. Let's move on. Comparing passwords. So we're talking about passwords a second ago, and we want to determine which password is less likely to be guessed. So you don't want anybody to guess your password, so you want a strong password. So which likely will be the password you would choose? Well, here's your choice. Choice A, a password with 6 numbers or a password with 4 letters, capital letters. Well, let's look at this. Now, let's deal with the numbers, like on Josiah's phone. How many different numbers on the phone? There were 10 different numbers on the phone. So far it's 10. For the first number, because remember, he has 6 different numbers, password. Well, the second digit number, what number could he choose? 0 to 9. There are 10 different passwords that he can choose for the second number. So again, it's 10. What about the third number? Hey, same thing. Hopefully you're seeing a pattern. So he has 10 different numbers that he can choose from. And for the next one, same thing. He has 10 different numbers. 10, 10. So he has a lot of 10s here that he can choose from. So since he has all those 10s, what are we going to do with them? We're going to use the counting principle, which tells us we have to multiply all of those 10s. So that would be 10 to the 6th power, which would be 10 times 10 times 10 times 10 times 10 equals 1 million passwords he would have. So he has 1 million passwords that he could choose from. Well, let's take a look at the capital letters. So now, capital letters, that's our alphabet. So what letters are in the alphabet that we can capitalize? A through Z. Well, how many letters are in the alphabet? Anybody know that? Huh? 26? Yes, 26 letters. So the first one could be 26 different letters. Let's choose a different color. 26 for the first number. Well, the second number, he can choose again a letter that's capitalized, and there are 26 of those letters he can choose. And the third letter, A through Z again, he can choose. So hopefully you're seeing a pattern just like we saw in the numbers. So 26 different letters he can choose from this time, and they're capitalized A through Z. Well, what are we going to do with all these 26s, Dr. Rob? Well, just like the 10s, we're going to use the counting principle to multiply these different combinations or choices that he can get. So 26 times 26 times 26, what does that equal to? 400,056 and 976 passwords. So which one is greater? 1 million passwords or 456 passwords? Dr. Rob, I'm going to go with choice A because 1 million passwords is much bigger than 456. That's not even 500,000. So he has more chance of getting his password least likely guess if he uses all those 6 numbers of 10 digit combinations. Good one, Josiah. Well, here's one for you. Determine which password you would be less likely to choose to be guessed. A password with 3 numbers or a password with 3 capital letters. So I'll let you work it out and you tell me what you think. Pause the video and let's see. This is going to take some time, Dr. Rob. Please give us a lot of time. That's okay. I'm going to give you till class time. So give me the answer in class. So I hope you understand what's going on. If you're not sure, watch the video, write down your questions, so that way we can answer them when we get back in the class. All right, let's play a little marbles now. So a bag contains 1 orange, 4 blue, 3 yellow marbles. So that's a total of 8 marbles. All right. What's the probability? And remember, probability is a fraction or a decimal or a percentage. And remember, it's between 0 and 1. So what's the probability of drawing a blue marble? So they want a blue marble, followed by a yellow marble in that order. Now they're talking about an order. Without replacing the first marble. So they don't want to replace the first marble? All right, let's take a look at that. So the probability of a blue marble, probability of a blue. How many blue marbles are there in the bag first? If you said 4, that's right. Out of how many marbles totally? 8. Thank you. There are 8 marbles, 1 orange, 4 blue, that's 5, and 3 yellow. That's a total of 8. I can reduce that down. I notice that's 4 divisible by both of those. So the probability of a blue is 1/2. So half the bag is full of blue marbles. Now, we want to get a yellow marble. Probability of a yellow marble. How many yellow marbles are there in the bag? 3. Out of how many marbles now? 8? No, there's not 8 in the bag anymore. Why not? They said without replacing the first marble that you took out. What does that mean? That means you had 8 marbles in the bag. So you have your little bag here, you have your 8 marbles, and they took out one and put it to the side. Hopefully it was the blue one. So if you took out one of the marbles that was in the bag, how many marbles are now left in the bag? That's right. If you said 7, 7 marbles are left in the bag. So only 7 marbles are left in the bag. So Dr. Rob, I got my 2 fractions. So the probability of getting a blue and then followed by a yellow, I gotta take those 2 fractions. What 2 fractions? My 4/8 or 1/2. I'll use the 1/2 because it's simplified, and I'm gonna multiply it by the second fraction because of the counting principle. 3/7. 3 times 1 is 3. 2 times 7 is 14. So my answer is 3 out of 14. That's the probability of getting a blue marble followed by a yellow marble. So we found the probability of a blue marble was 4/8, and the probability of getting a yellow marble is 3 out of 7. Why 7? Because they took out one of the marbles from your bag and did not replace it back in there. So they're talking without replacement. So the probability of blue and yellow, followed by yellow, would be 4/8 times 3/7, because the counting principle tells us to multiply. 4 times 3 is 12. 8 times 7 is 56. And if you reduce that down, I believe you can divide it both by 4. That'll give you 3/14 as we got in our answer. Nice question. We haven't done without replacement. That's tough. So here's one for you. See if you can get it. Bag contains 1 orange, 4 blue, 3 yellow marbles. What's the probability of drawing a blue marble followed by a green marble? Green marble? In that order, without replacing the first marble. Where's the green marbles, Dr. Rob? I don't see any green marbles. That's interesting. Is that possible? If you said it's not possible, guess what? You are correct. Probability of a blue marble would be 4 out of 8. And the probability of getting a green marble, once we took out, without replacing the first marble, hopefully you took out the blue marble, there's 7 marbles left, and there's 0 green marbles. So 4 out of 8, let's fix that. 4 out of 8 times 0 is 0. This is impossible. There are no green marbles. Impossible. So that's an easy one. So I hope you understood our marble section of compound events. So we want to talk now about the probability of an event not happening. When you Find the probability of not. It's the result of having the probability of or the probability of or the probability of not. It adds up to 1. That's always going to be true. So either it will happen or it won't happen. That's always going to be true, and it adds up to 100%. So the probability of event A happening plus the probability of event A not happening equals 100 or 1. So we write that as the rule: probability of A plus the probability of not A equals 1. So the main thing is it has to add up to 100%. So let's take a look at what we got here. Here we have a probability of not spinning an odd number. Odd number? I heard an even number. What's odd number? Well, let me get that out again. Definitions of even and odd numbers. A whole number is even if it's divisible by 2. A whole number is odd if it's not divisible by 2. So remember, odd numbers are not divisible by 2. Put that back. All right, so we don't want any numbers divisible by 2. So that's what we're looking for, not. So the probability of not. So let's find the probability of getting an odd number. What numbers are odd? So what numbers are odd? Well, 1 you can't divide by 2, 3 you can't divide by 2, and 5 you can't divide by 2. So there are 3 numbers out of 5, which is 60%. So I turned it to a percentage because I like percents too. Wait a minute. If 60% is the probability of getting an odd number, all I have to do is subtract 60% from 100%. Because either I'll get an odd number or I'm not going to get an odd number. So 100% minus 60% is 40%. So the probability of not getting an odd number is 40%. Well, what are those numbers that I need to get to win? That's the question. The winning numbers are 2 and 4. Those are not odd numbers. Those numbers are even numbers. So in other words, they're asking you to find the probability of an even number, and the numbers are 2 and 4. So that means don't land on the 2. Land on the 2 or the 4. Oh, notice I keep losing. That's why I don't like to gamble, because I keep losing. So you have a better chance of landing on an odd number. It's hard 40% of the time. That's not even 50-50. So don't gamble. Let's try another one. Find the probability of not spinning the number 5. So they don't want the number 5. Well, wait a minute. If they don't want the number 5, what numbers can we get? We can get a 1, 2, 3, 4. So the probability of getting those 4 numbers out of the 5 numbers is really good. It's 80%. And let me get my calculator just to make sure. Let's clear this. Type my fraction 4, 5, move over. And there's my fraction. I'm going to change it to a percent by multiplying it by 100. And I'll get 80%. So the probability of getting one of the numbers that are not 5 are 80%. So I can get a 1, 2, 3, or 4. Those are not 5. So I got 80% of getting it. Wait a minute. The probability of getting a 5 would be 20%? Interesting. So, Dr. Rob, looks like you went ahead of the game here, because your winning numbers are 1, 2, 3, 4. Those are not 5. So I went way ahead of it. So the probability of getting a 5 is 20%, because there's only one 5 out of the 5 numbers. And the probability, if I subtract that 100 from 20%, that'll give me the 80% that we got. So I went a little bit ahead of the game. Shame on you, Dr. Rob. Let's try to stay with the game, Dr. Rob. Probability is so much fun. Find the probability of not spinning a 5. So we don't want to spin a 5. Hey, didn't we just do that? And flipping ahead. So let's see. We just did not 5. What was the probability of not 5? Wasn't that 80%? So that was 80%. So the probability of not getting a 5 was 80%. Now let's talk about the probability of getting a head. Well, we did coin a little earlier. You can get a head or a tail, and that was 1/2. If I multiply that by 100 to get a percent, I'll get 50%. So the probability of getting a head is 50%. Now I'm doing compound probability because I'm doing two different things. So I have to use the counting principle with these two percentages. I'm going to multiply 80% times 50% because the counting principle tells us to do that, and that'll give us 40%. So we'll have 40% chance of not getting a 5 and getting a head. That was pretty interesting. So let's try another one. All right. Find the probability of spinning a prime number and not flipping ahead. What's a prime number? Well, let's pull this down. Prime number is a number which is divisible by 1 and itself, except 1. So we can't use 1. Known as prime numbers, such as 5. So they say 5. So 5 is a prime number. And 7, well, 7 is not on the spinner, or 11. So 1 is not a prime number, so I cannot use 1. So 1 is not prime. I only can divide this by 1 and its number itself. Like 2, I can only divide by 2 and 1, so 2 would be prime. 3, I can divide by 3 and 1, so 3 would be prime. 4, I can divide that by 4, and I can divide it by 1, but I also can divide it by 2. So that's not prime. That would be called a composite number. So let's put this back. So now that we got our prime numbers, so there are a total of 3 prime numbers out of all 5 prime numbers. And let's get my calculator. Let's clear this. Type 3 fifths. Move over. I want to change it to a percentage, multiply by 100, and that gives me 60%. So I have a 60% chance of getting a prime number. So that's good to know. So that means I can get a 2, 3, or 5, and that would give me a 60% chance of getting a prime number. Let's cut that out. Probability of not heads. Well, they don't want a head. That means they want a tail. Well, remember when we are flipping a coin, we get 2 options, head or tail. So that's 1 out of 2. So that's 50%. So the probability of a tail would be 50%. So not heads is what we would want, or what they're really saying is get a tail, Dr. Rob. So they don't want heads. So let's get that out of there. So the probability of not heads is 50%. Well, what are you going to do with these two percentages, Dr. Rob? Well, we're doing a compound event. Compound event means you're doing more than one thing together. So since you're doing more than one thing, according to the counting principle, you have to multiply those things. So I'm going to take 60% and multiply it by 50%. Let's delete that. And that'll give me 30%. So the probability of a prime number and not heads would be 30%. Okay, this is getting good. So I hope you're understanding what's going on. If you're not sure, rewatch the video. Bring in your questions to class because probability is a lot of fun when you understand what's going on. I have a challenge problem for you to do a little research. So here's my challenge problem, some reasoning. You're going to be assigned a 9-digit identification number, such as a Social Security number. Should you use the fundamental counting principle or a tree diagram to find the total number of possible identification numbers? Explain. That's a good question. I'm sure you already know the answer. Tree diagram. Check out my video on counting principle to see about that. How many identification numbers are possible? We can do that. Look at Josiah's problem. See how many he had possible. Research. Oh, we got to do research. Use the internet to find out why the possible number of Social Security numbers is not the same as your answer in Part B. So I wonder, what'd you get for Part B? And why is it not the same? That's interesting. So that's the challenge. Hope you meet it. So I hope this lesson was easy for you. If not, rewatch the video, bring in your questions, and you can also call Dial Teacher Homework Helpline at 212-777-3380, Monday to Thursday, 4 p.m. to 7 p.m. They'll be glad to help you out. You can check out my other study videos on YouTube. My channel name is Dan Robinson, PKMS. Subscribe to our channel. Give us a thumbs up if you like what we're doing. Write us a comment because I do write back. Check out our latest release, Math Prep 21, The Pandemic. Tweet me at drobmath1. So that's it, ladies and gentlemen. Hope you enjoyed the video, and I will see you next time. Bye-bye.